Hey everyone, welcome to the Notes on Radian Measure of an Angle. So hopefully you've heard of radians before, especially when we had to, when we were doing right triangle trig, and I said you have to make sure you're in the correct mode. You can't be in radians, you have to be in degrees. So radians are just another unit of measure for angles. Just like distances could be measured in inches, in feet, in kilometers, angles can be measured in either degrees or radians. So let's talk about here on this first page what it even means to be a radian. So first let's talk about some definitions here. The first one is an arc. We will do more with arcs when we get to the circle chapter, but an arc is a portion of the circumference of the circle. Circumference is like the distance around a circle. So in every other shape that's called the perimeter, but a circle has its own name for the distance around it, and it's circumference. So the length of an arc is the portion of the circumference. So the circumference can also be considered an arc length. So the length of an arc is traditionally symbolized by this lowercase s. In the diagram at the right, it can be said that the central angle, angle AOB, subtends arc AB. So this right here should be like more of a rounded. This is kind of funky looking, but this should be more of a rounded over the AB. Then we know we're talking about an arc. And the central angle here is AOB. So this one right there. So that symbol in there in that angle, you're going to see it quite a lot, especially in upper level math classes. But this is a Greek letter, theta. Many times that's the letter that is used for an unknown angle. So an angle symbol is usually this theta. Sometimes it's more like cursive looking. But on the SAT, sometimes that pops up and kids are like, there's some weird looking symbol in there. That's just a Greek letter, and it usually denotes a angle. So the central angle is because O would be the center of the circle. So if you draw two segments to anywhere on the circle, that is now called AOB, is called a central angle. So now, if the length of the arc here, S, if I was able to take this segment, or this piece of the circle, it's not a segment, sorry, this arc, if I was able to take it and straighten it out and make it the same length as the circle's radius, the measure of that angle that would be created is called a radian. So if R, the radius of the circle, is the same length as that arc, then the angle that's formed is called a radian. So the definition here, a radian is the measure of an angle that, when drawn as the central angle, subtends an arc whose length equals the length of the radius of the circle. So if I made that smaller, like if I made that angle, central angle there smaller, so that the arc that it intercepts is a lot smaller, that angle there would not be a radian. But if those two are equal, if that length and that length are the same, the angle that's formed is one radian. Okay, so when the radius r equals the arc length r, the angle theta measures 1 radian. So some clever person connected a very appropriate name, radian measure, to this type of angle. So when you go to higher level math classes, radians are going to be preferred over degrees for more theoretical work, because it allows us to treat the trig functions as functions with domains of real numbers rather than angles. So that'll make a lot more sense when you're in upper level math classes, but just know that radians are going to come back with a great force. So that's why we want to at least introduce you to radians in this class. So let's see the relationship between an angle measured in degrees and the angles measured in radians. So probably in middle school somewhere you did learn the formula for the circumference of a circle. In case you forgot it, I will refresh your memory. It's circumference equals 2 times pi times r. So 2 pi r. It's not 2 pi r squared, because a lot of people think that they combine area and circumference. It's just 2 pi r. So how many arc lengths of r could be wrapped around the circle? Well, if around the circle is 2 pi r, then it would be 2 pi. How many radians does angle theta rotate through in a complete rotation? Again, 2 pi radians. If the angle theta is completely rotated around the circle, how many degrees did it rotate? Well, full circle, we're more comfortable with degrees, is 360 degrees. So therefore, these two equal each other. Just like 12 inches equals 1 foot, 2 pi radians equals 360 degrees. So if the angle theta measured 180, what is its measure in radians? 1 pi radian. Okay, so a pi radian is equal to 180 degrees. And that is going to be the conversion we use. Just like I could say, 1 week equals 7 days, 1 year equals 12 months, 1 foot equals 12 inches, 1 hour equals 60 minutes. Like those are all things that are equal to each other. Here, 1 pi radian equals 180 degrees because a full circle is 2 pi radians. Therefore, a half circle is going to be pi radians. So 180 degrees is pi radians. All right, so if you were able to answer the questions on the previous page, you can use those results to set up a proportion to compare corresponding radian measures or degree measures of an angle. So here's the proportion. Radian measure over pi radians equals degree measures over 180, or R over pi equals D, the degrees over 180. When making a conversion between degrees and radians, put the measure you know and solve the proportion for the other measures. I, on the other hand, like to do this a little bit differently. For example, if I want to convert how many weeks is 10 days, I know the conversion between days and weeks is 1 week equals 10 days. Just kidding, 7 days. What am I talking about? Not in this world. Okay, so it's 7 days. So what I would do is, because I want the days to go away, I want days on the bottom because then they cross cancel. I would put weeks up top, and then I write the conversion. 1 week is 7 days. So this would equal 10 over 7, which is 1 3/7. And then my unit would be weeks. So it's 10/7 weeks. So I like to do the same thing here when I convert degrees and radians. I know that the conversion is a pi radian equals 180 degrees. So then I look at what I'm converting. Here, because I'm converting degrees, I want degrees gone. So I'm going to put 180 degrees on the bottom because these will now cancel each other. Okay, and then this is going to be pi radians up top. I would cross or multiply across, so 60 times pi is 60 pi radians over 180. I'm going to simplify this. It's going to equal, you could write it as pi over 3 or 1/3 pi, and then I'm in radians. I'm going to show you how to do this with the proportion up top as well. If I have R over pi equals D over 180, I'm going to plug in what I know, and that's the degrees. So for D, I would plug in 60 over 180. Notice if I cross multiply, I get 180 R equals 60 pi, right? That's my cross products. And then to solve for R, I would divide both sides by 180. So that is exactly what I got. I just maybe did it in fewer steps. I don't know, maybe it's the exact same number of steps. But when I convert, I like to just get rid of the units that I don't want. All right, the second one here is 135 degrees. So again, what I like to do is multiply, because when I multiply by 180 degrees over pi radians, these are the same. Just like 1 foot is equal to 12 inches. If I put a foot over 12 inches, that's just going to simplify to be 1. Same thing here. So now the degrees cancel. I'm left with 135 pi over 180. I would simplify this. I could use my calculator. I could math frac it. And I could write this as either 3 pi over 4 or 3/4 pi radians. All right, for part C, pause the video, try it on your own, and then I will show you the answer, and hopefully you got the same answer. All right, hopefully if you did this correctly, you got 8/9 pi, which is the same thing as 8 pi over 9. Either way you express that is totally fine. So now we're going to do the reverse. We're going to go from radians to degrees. So here, if I have pi, 1/6 pi, That's the same thing as pi over 6. And the reason I want to write it that way is because I want to get rid of the pi. If I want to convert this to degrees, 180 over pi is equal to 1 over 1 pi radian. So let's cross out our pi's, and we get 180 divided by 6. This is going to equal 30 degrees. So 30 degrees is the same thing as 1/6 pi. Part B, same thing. I want to get rid of the pi's. I want radians gone. So I put pi on the bottom. I put 180 up top. These cancel. I multiply across. 180 divided by 4 is going to equal, I could use my calculator to simplify that, but it's 45 degrees. And I'm done. All right, for part C, pause the video. I want you to try it yourself and then compare answers. And if you don't get the correct answer, make sure you ask in class tomorrow. All right, and that brings us to our last set of problems here, which is number 3. We're going to convert each radian measured to degrees, and we're going to round our answers to the nearest 10th of a degree. So here we have 2 radians. So if this is in radians and I want my answer to be in degrees, I know I have to have 180 degrees over pi. Now, in this case, there is no pi to cancel from my original, so I'm just going to multiply across on top, 360 divided by 1 times pi is pi. So it sets round to the nearest hundredth. Press pi on your calculators. Those of you with a graphing calculator, it's the blue option above the like carrot top kind of exponent. So there's a button that looks like this above your division. And right here, you should see that it's pi. Most calculators. Other calculators, it might be somewhere different. If you can't find it, make sure you locate it and you know where it is. If not, ask in class and I will help you find pi on your calculators. But I would do 360 degrees divided by pi, and I get 114.59 degrees. If you can't find it, make sure you ask me when we see each other. All right, and now part B, same thing. We want this to be in degrees, so I'm going to multiply by 180 degrees over pi. And what this would equal is 585.54 divided by pi. Again, press that pi button on your calculator and we get approximately 186.38 degrees. So just to reiterate, I just want to make sure that we understand how this works. Like if I said 13 feet is going to equal how many inches? And this is what I'm curious about. I would start off with my 13 feet times. Now because I want feet gone, I would put feet on the bottom, inches on top. 12 inches is equal to 1 foot. I can cancel the feet away. And now I do 13 times 12 is 156, and then this one's just over 1 times 1, so it's 156 inches. And that's all we're doing with this. So radians and degrees, the conversion is not terrible. 180 degrees equals 1 pi radian. So you just put the unit you want gone has to be on the bottom so they could cancel each other out, and then, you know, fill in and multiply. One last thing I want to mention before I let you go is that radians are not a unit, so we don't write rad really. I wrote it in some of these problems just to help you keep track that it's radians, but radians really have no dimension. They're not a unit. So if you ever have something written like sine of 70 and there's no degree sign there, then you are to assume and you are to know that that is in radians. So this would be sine of 70 radians. If I write this, then that is the sine of 70 degrees because there's a degree symbol. Okay, so that symbol being there is really important. Okay, so just to know the difference, if there's no degree, it's not in degrees, it's in radians. If there's a degree symbol there, then the angle is in degrees. All right, thanks for watching. Have a good one. Bye.